This is David WA9ONY. I have a BaoFeng UV-5R. I want to set it up so it can be scanning just the FM amateur radio operator FM frequencies. To do this, we have to know what frequencies to program in the memory locations of the UV-5R. To help us do that, we will use two web pages. One web page is the ARRL band plan, and we'll look at it here on the screen. It goes from 144 to 148 megahertz. And in it, we'll find that there are three sub-segment bands of repeater frequencies and two segments of simplex frequencies. A repeater takes a signal, receives it, and immediately transmits it out. Simplex does not involve a repeater. The receive and transmit frequencies are the same in simplex. A repeater, because it's transmitting and receiving at the same time, needs two different frequencies. A receive frequency to receive the signal, and then its output frequency that it transmits, and that output frequency is the frequency we want to program in the UV-5R. So scanning down this band plan, the first band of FM repeater frequencies, we come across the input. Again, we're not concerned about receiving the input frequency, we're concerned about receiving the output frequency. So repeaters are always referred to their output frequency. So down here, we're going to see the output frequency associated with that input frequency. So this is the first band, and its input frequency was 0.6 megahertz lower than its output frequency. Next, as we move down through the band plan, we'll see the first simplex. Simplex, again, does not involve a repeater. And in this band, there is the national calling frequency of 146.52. So this simplex calling frequency is important that we have that in our BaoFeng UV-5R. And you'll notice that this national calling frequency is in this segment of simplex frequencies. Next, we'll continue. We'll run into the repeater, the second repeater band output frequencies. And just like the first, it's 0.6 megahertz lower is where we're going to find the input to that repeater. And then the third band is right next to the second band output, but the input frequencies to this is a positive 0.6 megahertz, and that's these frequencies here. And finally, we end up with the second band of simplex frequencies here. So these are the frequencies that we want to be aware of. Now, I'm going to go to the repeater book, and the repeater book is going to tell us an important piece of information that varies from state to state. I'm located 16 miles from Portland, Oregon, so I'm going to use the Oregon repeater book for Oregon. And we can see these frequencies here are the repeater output frequencies. We can see that 145.1100. We notice that there's two repeaters on this, but since 2 meters is line of sight mostly, these two repeaters not being in the same part of the state, they do not interfere with each other. Now, we notice that to go from the next repeater, this is 145.130, there's a 20 kilohertz difference. And again, as we see the next step, there's 1.3 to 1.5, that's a 20 kilohertz difference. 1.5 to 1.7, 20 kilohertz. So in the state of Oregon, repeaters usually, there are a few exceptions, are incrementing by 20 kilohertz. Some places it may be 15 kilohertz. So our BaoFeng UV-5R, for the first band of repeaters, will start at 145.11 and then use the increment the UV-5R frequency in VFO mode by 20 kilohertz and start programming each one of these frequencies. We will do that until we run to the end of the first band of repeater frequencies, and that's going to be 145.49. So that completes the first band. Now, next is that we're going to come across these simplex frequencies. So if we take a look at the simplex frequency 146.52, and it's in the middle of this simplex band, we'll make sure that we have that, and then we basically subtract and add 20 kilohertz increments until we cover the complete simplex band. So that's how we're going to take our simplex programming. The second band of repeater frequencies, which is going to start here, 146.61, and again, we can see that there's an increment, but in this case, there's an exception. It's only 10 kilohertz, so we'll take care of that. But after that, we go from 6.2 to 6.4, and we'll start scrolling down here. After 6.4, we get 0.66, 6.8, so again, we're back on the 20 kilohertz incrementing. We will increment this until we get to the end of the second band of repeater frequencies. And that's going to be down here, getting closer, closer. There we go. So here's the last repeater of the second band of repeater frequencies, 146.98. The third band is going to start here, 147.000. And notice the offset frequency. It represents the off frequency for the input, minus 0.6 megahertz. This is positive 0.6 megahertz. And again, we take a look at the increments, and it's 20 kilohertz like we saw before. So we reprogram all these frequencies in, and we'll eventually get to the bottom. And we'll notice that there's an exception. There is, again, this 0.93 instead of basically 148.000, which we can't really transmit on because that would have its sidebands outside amateur radio operation. It's also interesting to note that this is a D-star, which is a digital repeater, and we cannot receive digital communications on the BaoFeng UV-5R. We can receive FM, but not digital voice like D-star. So these are the frequencies that we will program into the BaoFeng UV-5R. There's approximately 70 of these frequencies. And when we have those in the memory location, then we'll be able to go to the scan capability and choose different scan types, and we'll only scan the amateur radio frequencies looking for activity. Once we find activity, we can determine the repeater by its call sign ID, that may be in Morse code or in voice transmission, and then start to build up a list of active frequencies that we'll probably want to listen to depending upon the types of operation and the communication nets and so forth on those repeater frequencies. This is David WA9ONY 73 and QRT.